Welcome to our Core Networking for Modern IT Support Professionals series. In this first video, we will share lectures and demos on OSI Layer. The target audience should be IT professionals who want to learn networking from theoretical to practical format. That's very important. Theoretical to practical. And I will explain that in a second. And our aim is basically to looking for advanced careers or looking for foundational IT knowledge where let's say you have landed an IT job and now you want to move up in your career, whether you want to move into cybersecurity, cloud, anything infrastructure, anything where you have to go and be that technical IT professional, you need to know the modern networking. And when I say modern networking, that doesn't mean it's something new. It's just that the concept of how our trainer is going to teach is going to be related to cloud and cybersecurity in our mind because that's most of where companies are moving. We are hybrid right now. So we have on-premises building where we have servers, and then those type of servers are connected and services are connected to cloud, and it's basically a hybrid type of environment in most cases. Whether it's a total 100% classic or 100% cloud, you still need to know about networking because that's where people get stuck. They can move on in their careers at the advanced level, or they're stressed because a lot of us, we just don't take that time on the theoretical side and also the practical side. So that's the whole goal of this video. For JSS member, where are this type of content will be updated. So if you go to the roadmaps and you go to the transitioning skills roadmap, this is for the people who want to transition out of IT support. And then when you want to get really serious about networking, that's where the network and systems administration course, skills course, we have that available. So in this course, everywhere we will start updating our content on OSI, DHCP, DNS, and these are going to be huge lectures with a lot of theoretical side of it, then demos. So yes, our goal is to make sure that this is the core. This is where we need to teach things, where we need to explain things. So you will have to have that mindset. If you don't have that mindset, then unfortunately, getting to the higher levels is something that is going to be a pretty hard road for you because if you don't do these foundational skills, your base is going to be weak. Whether you get a big job or not, that's not the whole point. The point is that how less stressful you are at IT jobs. We will also have this course and the new material available on Udemy. So if you follow Udemy, you can also take it over there. So let me actually open the course quickly to overview and quickly show you before you spend next 2 hours, you will know exactly what you're going to cover in this video. So as you can see, Kamran, who is basically the trainer of this course, is going to explain what he's going to cover first, and then some troubleshooting, and then there's going to be a perspective of cybersecurity and network security, and also touching the cloud. So then you are at the current market level. So once the video start, there's going to be a lot of explanation, a lot of theoretical, back and forth understanding things from PowerPoint perspective, because at the end of the day, we want you to know this stuff. This is now for people who want to move up in their career, and you just can't copy paste things. You can't just go to the Google and just get a script and just put it on your network. At some point, you will get stuck, and you will have to have. Then that's where you started asking yourself questions like, "Why is my foundational knowledge so weak? What can I do?" So this is the answer for that type of issues. So now here you go. We have all of that covered. Very hard work has been done. So you can see there's also demos that then we went through all these demos right here with doing Wireshark to just make sure that it's not just theory, also showcasing things in a practical format as well. And then we also show some of the cloud stuff, and it goes to more and more labs because some things are extremely theoretical and you just can't do too many labs. But then, of course, we have other things that we can do a lot of labs. So you will certainly see more labs into these videos. But just imagine this is just the only OSI layers, and we almost spent 2 hours on it. And of course, each and every core skills that we're going to cover is going to be almost 1 to 2 hours type of content. So prepare your mind. That's all I'm saying. Prepare your mind and be positive around it. Say that I want to do this. If I want to move up in my career in IT, I want to go to the bigger roles, bigger salary. Then yes, you have to take this time and just do it once, and you're good to go. Thank you, and now Kamran will take over.
Hello and welcome. This is Kamal Mahmood, and today's topic that we are going to talk about is OSI model. So let's head over to the next slide, which is talking about the agenda. So since this is going to be the beginning of my program, so that's why I'm going to take a little bit time over here and will unfold some topics that I want to cover in this program. So as you can see, this module is about OSI layer, or this program or this session is all about OSI layer. So I will be talking briefly about the 7 layer of OSI model. Okay, and when we will hit this topic, I will be briefly talking about each and every layer. But apart from that, as you can see, I have some another major topics, and one thing I missed over here. The first topic that I'm going to hit after OSI layer is analyzing using Wireshark. If you're already familiar with this tool Wireshark, then that is good enough. If you're not, then I'm going to give you a detailed overview how we are going to use it and why do we need to use this analyzing packet tool. Okay, so basically whatever I'm talking in a OSI layer, I will be proof using Wireshark. Okay, the second major topic that we are going to hit is troubleshoot. You might be a very good network administrator or network engineer. If you don't know how to troubleshoot a network, I don't think so you are going to make it. Okay, so this is the idea, agenda, and objective of the JSS. Okay, to make you prepare for the future. Okay, if we want, we just could teach you OSI layer and can finish the this session over here, but we do not want like this. Okay, we want to make to prepare for the future. So that is why troubleshooting is one of the very important aspect in the life of network engineer. That is why we are going to cover troubleshooting as well. So this is going to be the program for the beginners, for the so that is why we do not want to go a lot in detail. So we will be just scratching the surface of every the topic that we are going to cover in this session. The third very important aspect is network security. And you as IT nerd, network engineer, system administrator, or even having IT knowledge, everyone has a clear idea about what network security is. And if you are even a standalone user for this computer, you might be facing this issue on day-to-day basis. So that is why we are adding network security concepts in the same program, so you have a very good understanding how you are going to face cybersecurity or network security issues. Okay, the fourth major topic that we are going to hit is cloud. Why? Because this is where things are moving. Sooner or later, everything is going to transform into cloud. Okay, although this transition is very slow, but you can see, the company that currently I'm working in, they are 100% on cloud. They have like 10% data center physically in their location, but seriously 90% they are using AWS and Azure. So just you can imagine the power of cloud. So that is why we have included this cloud section as well in the same program. So as you can see, four major topics: one, analyzing Wireshark, and the second one is troubleshooting, third is network security, and fourth is cloud. Okay, because as I said, the JSS want to make you prepare for the future. The last but not least, common interview question and answers. So from the perspective of OSI layers, whatever the common interview questions appears, I'm going to list down in the last slide as well. And you, as an assignment, you have to find those answers and you need to submit to JSS. And this agenda we are going to follow throughout this program. Okay, so you have to make it yourself ready. And this session is going to be the lengthiest session because the opening session is always going to be lengthy. So I am planning to divide this session into two portions. Okay, so you do not get bored. So let's head over to the next slide, which is talking about the OSI model, or what is OSI model. So first thing first let's read about this paragraph that I prepared for you. The open system interconnection OSI model describes 7 layers that computer system use to communicate over a network. It was the first standard model for a network communications adopted by all major computers and telecommunication companies in the early 1980s. So you can imagine how old this OSI model is. OSI is a model or system that help you break down network functions. So as you can see over here on your right side, the seventh layer of the OSI model is application layer. Okay, either you can start from bottom up approach or top down approach. Okay, whatever you is feasible for you, you can do it. But I will start since this is the first one, so that is why. Although physical is the first one from the bottom, but this is all always it is represented. The application always comes first, but it is going to be your seventh layer of OSI model. So this application is 7 layer. Then we have presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. If you are, if excuse me, if you are saying this for the first time, then you have to remember this by heart. Okay, but sooner or later, when you will get familiarized with every layer of this OSI model, trust me, this thing will be on your fingertips. You will immediately something pop up in your mind that yeah, this thing works at transport layer. Okay, yeah, this thing or device works at network layer. Okay, and I'm very hopeful that after the end of this session or the program, you will be having very clear understanding of each and every layer. Okay, so in the first para it is saying this is the OSA model describe the 7 layers as I have shown here. This it the standard model for network communication, how it happens. For example, we have two computers and somehow they are connected with some wired cable, could be cat 8, cat 6, or whatever might it be. When this computer wants to communicate with this computer, they are going to follow these OSI layer model. Okay, and when I will be describe each layer, then you will be having very good understanding and idea. But this is just a flyby overview. Whenever you are going to communicate over a network, you always have to have this OSI layer in your mind. OSI model or system that help you break down network functions. So as it is mentioned clearly over here, breakdown. If you have heard this word, divide and conquer approach. So basically, uh, instead of giving one layer, one big layer, and then you will end up achieving nothing. What they did, they break down these all one layer into multiple layers. If they want, they could have single layer, yeah. But why? Because they have divided. these all into sub layers to make you understand at every layer what is happening and how you are going to troubleshoot uh, particularly that layer. Okay, so that is the basic idea behind having the breakdown. So you can divide and conquer. I hope you get the idea. Okay, so I have given a very layman example over here. If you are going to construct one house, how you are going to construct? Of course, you need to break it down. First thing first, as you can see, this is going to be the first. You are going to purchase a land and then you are going to put some foundation. In the second step, you are going to stand a structure over here, as you can see over here, and then you are going to construct. In the third step, you are going to install some insulation, waterproofing, and then electric kind of stuff. And then, as you can see, the structure has been built. In the final step, the whole building or the whole home has been constructed, and this is going to be your finished touches. On the same basis, we are going to construct our hardware devices as well. So that is why OSI layer comes handy. For example, if I give you example, you are going to open one hardware manufacturer company that is basically going to manufacture these cables. Okay, but how on earth you are going to make this cable compatible with this switch and compatible with this network interface card? How? Of course, you are going to follow some governing body or you are going to follow some rules that is governed by ISO, not to confuse with OSI. OSI Open System Interconnection Model, whereas ISO is International Standard Organization who govern these 7 layers of OSI models or the rules. And basically what happens on each layer, on the basis of that you are going to follow those rules. You are going to manufacture your this cat 8 cat 6 cat 9 cable that will be compatible with these Cisco switches or network interface card. If you're not familiar what NIC card is or what Cisco switches switches are, don't worry, this just imagine this is just like some hardware device, or you can, in a short or layman example, you can say this is some mini computer. Okay, even if you want to manufacture a computer, you always have to follow some rules, and those rules governed by these ISO, the organization. So you always have to you always have to follow the rules. Okay, so this is the whole idea having OSI model. Another aspect is troubleshoot. I'm going to give you one scenario, the real example when I joined the company for the first time, and I received a call from the employee. He said my internet is not working. So just immediately went over to his desk and I checked. Yes, the internet was not working. You know, the first thing that came to my mind is this OSI layer approach. I went to this layer first. Physical layer, when I will be talking about the physical layer in the next slides, this is talking about the physical things like cables. Okay, so first thing came to my mind is, do we have proper cabling for this user or employee? So when I checked the RJ45, it was unplugged. Okay, so instead of wasting my time troubleshooting all above layers, I just jumped over to the physical layer and just checked the cables or even the power connectivity. Okay, so this is the whole idea of having OSI model. So you have a very better understanding and the approach when it comes to troubleshooting. So I hope you get the idea. So let's head over to the next slide, which is actually going to start our seventh OSI layer, which is application layer. So first read about the paragraph. It is saying the seventh layer of OSI model is application layer. This is the only layer that directly interacts with the data from the user. Which means that your end user, employee, uh, the user, or no matter who is he or she is, directly connected with your application layer. From there, he or she is going to give input. So basically, user is going to input the data through various application at this layer. The input application could be, so this could be software application like web, browser, email clients rely on the application layer to initiate communications. Okay, but it should be made clear that client software applications are not part of the application layer. Rather, the application layer is responsible for the protocols and data manipulation. That software relies on present meaningful data to the user. And at the seventh layer, the most common protocols that are being used are HTTP, HTTPS, SMTP, then SSH, FTP, POP10, and many more others. Okay, so these kind of protocols are being used on application layer, which is going to be your seventh layer. So basically, what this paragraph is trying to say, your user is going to directly involve interacting with your application. This might, this could be like web application. This could be like some mail application, email application. Okay, this could be something like file transfer application, FTP server, or could be anything. Okay, so user basically providing its input to these applications. But all application does not come under layer 7. How? For example, we have some games sitting on this computer like solitaire or could be chess. Okay, so when you are playing these games, do you think you are going to internet? No, you are just playing these games locally on this computer and you are going to close this game. But on other hand, when you are going to use web browser, on the URL box you are going to type www.jobskillshare.org. As soon as you hit enter, what is the next thing it is going to happen? It is going to reach some server that is related to job skill share, and it is sitting far away from your location. So it means you are going your boundaries to reach out this server. So it means in order to reach this server, you have to follow some rules, some applications, or some devices. Or for that, that is why it is mentioned that all application does not comes under OSI 7 layer. So whenever you are going to go beyond your computer, maybe even in your local area, even in your local area network, if you are going to hit some file transfer protocol FTP server, okay, you have to follow these OSI layers. But if you are playing some games like solitaire, chess, that is locally installed, you are not going to follow OSI layer. So this is what is trying to say this paragraph. Okay, I hope you get the idea. So seventh layer of OSI has to do with application layer. The sixth layer of OSI is presentation layer. So first read about the paragraph. Sixth layer of the OSI model is primarily responsible for preparing data so that it can be used by the application layer. Okay, so whatever methodology will be happened on sixth layer is going to interact. Basically, it is making itself prepare to interact with the application layer. So basically, layer 6 makes the data presentable for application to consume. The presentation layer is responsible for translation. This is going to be very important. Translation, encryption, and compression. So these three things happens at presentation layer: translation, encryption, and compression. And we know what compression is like. If we correlate it with the zip or WinRAR, it is going to compress that file. Encryption, whatever the data is, it is going to encrypt into. For example, I have character A. It is going to, let's say, I forgot what A stands for in ASCII characters, but let's say it is 97. Okay, so it is going to encrypt. Then this is the translation. So as you can see over here, it is going to translate whatever the image we have. This is in the JPEG format. It is going to translate into this gibberish data, and then vice versa. Gibberish data is going to translate into this JPEG format. Let's suppose this was Microsoft Windows and this is Mac operating system. These both should know or understand the idea of JPEG format, JPG format. Let's take this example. Is if my Microsoft computer knows what is JPEG format, it can translate this gibberish into JPEG and JPEG into gibberish. Whereas when I'm going to transfer this file over a Mac computer, and unfortunately my Mac computer does not have understanding about JPEG format, then it is not going to translate from gibberish to this JPEG format. No, it is just going to give me another gibberish data, just like this. So it means both computers should have a language of love, basically. They should have understanding about how to convert this format to JPEG format and vice versa. So, two communicating devices communicating may be using different encoding methods. So, layer 6 is responsible for translating incoming data into a syntax that application layer of the receiving device can be understand. Okay, so whatever it is going to translate, the application layer, which is at the seventh layer, should have a clear understanding of this syntax. If the devices are communicating over an encrypted connection, layer 6 is responsible for adding the encryption on the senders and as well as decoding the encryption on the receiver's end so that it can be present the application layer with unencrypted readable data. So as I said, encryption is also happens at the sixth layer. So whatever the data, for example, I'm surfing the web using www.jobskillshare.org. So whatever the contents or the page I'm going to receive on my computer will be in an encrypted format if it is secured, SSL or HTTPS if it is using. Okay. So both parties, by the way, these SSL keys will be installed locally in my computer whenever I'm going to serve some secure website. So those SSL security encryption keys will decrypt my whatever the data is coming from job skills here, and it is going to show me the website. So this is basically I'm going to give you a very very advanced knowledge, but no problem. You just keep it. If you can digest, that is good. But this is whole idea of having the presentation layer. It is going to translate, as I mentioned over here, encryption like SSL kind of things, HTTPS, the secure things. It is going to encrypt and decrypt, and the compression. So this is what presentation layer is used for. Then we have a session layer. As the name suggests, session. We are going to create a session for some time of period. So let's talk about the paragraph. The fifth layer is responsible for opening and closing communication between the two devices. The time between when the communication is open and closed is known as session. The session layer ensures that the session stays open long enough to transfer all the data being exchanged and then promptly close the session in order to avoid wasting resources. This layer is also responsible to synchronize data transfer with the checkpoints. Okay, so what this whole paragraph basically is talking about, whenever, for example, this is my laptop and I am trying to access the website www.jobskillshare.org. As soon as I hit enter, it will reach to the server. Server will send some cookies which will be having information of session, that how long we will keep this session connected. And if the session cookies are saying unlimited time, then no matter you open that session for maybe 2 days, 3 days, session will not be closed. But have you ever came across with the bank websites? If you keep that session open for 2 to 3 minutes or maybe 5 minutes, depend on the session cookies, it will be teared down automatically. The session will be disconnected automatically after some time. So that is why session layer is very important aspect. As you can say, manage connection between client and server. Okay, so it will keep connection open unless until you are using that website. Maybe you are doing some kind of transactions. So as you will proceed with the transaction, the session time will be incremented. But if the session is idle for some time, it is going to tear that session. So this is the whole idea having the session layer. So here is the example. If a system is sending a 800 pages, adding checkpoints. So this is it is going to give me the idea about how the checkpoints works in session layer. So for example, if you are sending 800 pages, adding checkpoint after every 50 pages is recommended. This ensures that 50 pages unit is successfully received and acknowledged. Okay, so we have to basically send all 800 pages, but checkpoint is added after 50 page. So once these all 800 pages will be transferred to this server successfully, then our session will be closed. Okay, so this is the main idea of having a session layer. So let's set up the next slide, which is talking about transport layer. And as you can see, I didn't have enough space, so I tried to squeeze all into a single slide, because time is very crucial and we don't want to waste your and mine time as well. So let's very quickly talk about the transport layer. The fourth layer of the OSI model is the transport layer. So sorry, I have said fifth layer. This is the fourth layer. Okay. The fourth layer of transport is the transport layer. As the name suggests, you are going to transport some data This is very important. For example, this is my client PC, this is my server PC. If I want to transfer some file to this server or vice versa, we are working on a transport layer over here of the OSI model. Okay, so layer 4 is responsible for end-to-end communication between the two devices. So as you can see, this is end-to-end communication. So our final piece of information is being transmitted or received, happens at transport layer. This includes taking data from the session layer. So as you can see, we took the data from the session layer. So this is how all layers are dependent on each other. If you are thinking that you can take out one layer from the OSI model, this is not possible. So this includes taking data from the session layer and break it up into the chunks called segments. So this is going to be the very important thing, segment. Because if you have, let's suppose, 1 GB of file, and do you think you are going to send 1 GB file at once to this server? It is not possible. What you are going to do? You are going to break it up into a small chunks. So this 1 GB data, you are going to divide into, let's suppose, 10 MB, 10 MB, 10 MB, and so on. So first 10 MB will be transferred, then second 10 MB will be transferred, third, and so on. So this is what it's saying. And these, whatever these things are, these are called segments. Okay. So before sending it to layer 3, the transport layer on the receiving device is responsible for reassembling the segment into the data the session layer can consume. Okay, so as I said earlier, 1 GB data that is divided into chunks will be sent to the server, and server will be responsible to reassemble these data. For example, it is tagged with 1. This is tagged with 2, 3, 4, 5. Okay, so when this server will receive these segments, it is going to reorganize these packets in a sorted fashion, 1, 2, 3, 4, 5, 6, and so on. So that is why we receive the data in accurate form. So this is the whole idea. So at transport layer, whatever the PDU, by the way, on every layer, whatever the data is being transmitted is called PDU, protocol data unit, or packet data unit, protocol data unit, packet data unit. Okay, so whatever the data is being transmitted is called PDUs, and then this PDU when reaches transport layer is called segment, and when we will reassemble this one here, this PDU, it is going to be called data once again. Okay, so this is the whole idea. The transport layer is also responsible for flow control, error control, and there is another thing called windowing, sliding window, and these all things we are going to cover a lot in detail when we will hit this uh, TCP or UDP section. Okay, so flow control determines an optimal speed of transmission to ensure that the data or ensure that a sender with a fast connection does not overwhelm as a receiver with a slow connection. So let's say client PC is fast enough. It has a very good speed, high processor and RAM, memory. It can just handle ton and ton of data in a seconds. Whereas our server, this is very slow. So let's say if I want to transfer 1 GB data all at a sudden. So what will happen? Server will be down. it will be overwhelmed. It will say that I cannot handle your query at this speed. Okay, so this is also one of the feature happens in the TCP or the transport layer called flow control. And the server will determine how much data you have to send me at what speed. Not the sender will decide. The receiver will decide at what speed you have to send the data. Okay, so this is the main idea behind it. Transport layer protocols include the transmission control protocol TCP and the user datagram protocol UDP. Also, the ports also used as this. For example, well-known ports like 80, 8080, 443, and random ports. That is why I have mentioned here this thing, the chart, the port number. Just by looking, you if you want to be a very good network engineer or network administrator, you have to focus on these remembering these port numbers instead of FTP, SSH, telnet, and these kind of things. Okay, just by looking this 53, suddenly this thing came or pop up in your mind that this is they are talking about DNS. If I'm talking about 110, it means it is talking about the mail exchange server protocol, which is POP3. Okay, so you have to be clear on understanding port numbers. So if we are talking about the service, which is file transfer protocol, FTP, FTP is basically used, for example, if a client want to send some files over a FTP server, then FTP server will open two ports like 20 and 21 for the client available. So client has very clear understanding that 20 or 21 belongs to FTP. Then this only going to transfer the data. Okay. Then similarly, we have SSH. And by the way, we have telnet here as well, if it is not there. Yes, telnet 23. It is mentioned there, it unsecured, not secured, by the way. In back in old days, whenever, by the way, telnet, why we use telnet? For example, we have this computer and I am sitting far away from this computer in some another department and I want to access my server. So I will be using maybe telnet, although we use RDP for accessing Windows Server, but just for the sake of simplicity, we are using telnet to access my server. So basically, to first of all, the server should have 23 port open to accept the queries. So I will telnet using this port, and it will send me reply back, and then I will have the connectivity with my server. But in the telnet, what used to happen, whatever the data username or the password is being sent over this wire are clear text. Okay, so whatever information I'm going to send over telnet, this is clear text, and if some hacker is sitting in between, they can have a hand on that password and they can access my server. So that is why secure shell came into play to secure our connectivity. So secure shell is use port number 22. So this time my server will open port 22, and same way like we access using the telnet, we are going to use SSH to access my server, and it is going to provide me the access. And this time if some hacker is sitting over here, some bad guy is sitting over here, and they are trying to access this my whatever the data or the contents, it will be encrypted and they cannot decrypt. So this is the main idea. So I'm not going to waste my time describing these all ports and services, but just I'm going to give you an idea. Then similarly, Telnet use 23, a simple SMTP use 25, DNS use 53, HTTP use 80, and this is not secure as well. That is why 443 HTTPS SSL TLS is being added to secure our web communication. Similarly, we have POP3 110. 123 is used for network time protocol NTP, and then this 143 is for internet message access protocol, and 161 is used for SNMP. Uh, the two main transmission protocols are being used are TCP and UDP. So just keep it in your mind. On transport layer, as I said, transport is used to transport our data. So data is being transported using two main protocols are TCP and UDP. And by the way, we are going to cover TCP and UDP into their own section a lot in detail. So you don't have to worry. So let's head over to the next slide, which is talking about the network layer, and one of my most favorite layer of OSI network, because this is always talking about routing. That is why. So how the data uh, will be sent from source to destination in an optimal fashion. So let's talk about what this paragraph is saying. Third layer of the OSI's network is a network layer, which is responsible for facilitating data transfer between two different networks. Logical addressing happens over here. Okay. Apart from the logical addressing, we have physical addressing. In contrary to the logical addressing, we have physical addressing, and that is we are going to cover in the second layer of the OSI model. So you don't have to worry. Logical addressing happens here if the two devices communicating are on the same network. Then the network layer is unnecessary. The network layer breaks up segment from the transport layer into the smaller units called packets. If you remember, in a transport layer, whatever the data uh, we were using there were called segments. But as soon as these segments reach to network layer, now the definition has been changed and it is called packets. So in a networking environment, if two professionals are communicating with each other, and one professional is saying to another one, we are facing some segment issues. Just quickly, this thing pop into your mind. They are talking about the transport layer. But if the guy is saying, my packets are stuck or my packets are in a queue, we have to provide some quality of insurance to my packets, QoS to packets, then he or she is talking about the network layer. So you have to look out on this, okay? On the sender's device and reassembling these packets on the receiving device. So just like in transport layer, the segments, the sender receiving those segments and reassembling in the same fashion in the network layer. When this router is going to send one packet from source to destination router, they are going to divide into chunks, and they are going to reassembly those packets at the receiving end. The network layer also finds the best physical path for the data to reach the destination. This is known as routing. So this is the best definition about the routing. Where is the best path? Best physical path. This is the thing. Best physical path. Okay. For example, let's say uh, This is ISP1, this is ISP2, and these are somehow connected with some another routers and routers. They are somehow connected with each other, and this is the server of job skill share server. And this PC wants to communicate with this server. So uh, the user will type www.jobskillshare.org. As soon as it hit enter, the information will be sent to these routers first. Now these routers has to decide on the basis of best path. Maybe for the ISP one, the path is much shorter as compared to ISP2. So that is why the path will be followed like this way to reach. So this is all things happening at network layer, where we are talking about the best physical path to reach the destination. And this thing is called routing. And by the way, routing we are going to cover a lot in detail. Network layer protocol includes IP, the Internet Control Message Protocol, and this ICMP. By the way, whenever you are going to ping use ICMP. And by the way, ICMP has one request and one reply. If you are going to ping, if you are familiar with the ping, that is fine enough. Otherwise, keep this discussion to this session. And once we will hit this ping its own topic, then we are going to talk about a lot in detail. But the ping is going to identify whether my this device or this device is alive or not. Even if this computers try to send a ping to this computer, the whole idea behind it is just it is pinging to check whether this system is up or not. Okay, so this thing is happening at network layer. Then we have protocols like IGMP, RIP, EIGRP, OSPF, IPsec suite. These all sections we have covered in CCNA topic. And my recommendation to you after you finish this program, this basics, this is going to be your destination, CCNA. And seriously, JSS cover these topics a lot in detail. Even just the IPsec VPN, I think we have more than 10 sessions just talking about the IPsec VPN a lot in detail. So whatever these routing protocols um, happening on this layer is called network layer. RIP, EIGRP, OSPF, they all belong to this OSI layer, which is network. The second layer of the OSI model is data link. And I told you in the last slide, it is all about the physical addressing, whereas the network layer is talking about logical addressing. So let's read about this paragraph first. Second layer of the OSI that is data link layer, which is very similar to the network layer, except the data link layer facilitates data transfer between two devices on the same network. So in network layer, when source and destination are on different networks, they are on different network, then network layer comes into handy. But opposed to network layer, we have a physical layer. This layer happens, or at this layer, when the source and destination are on the same network. same network. Data link layer comes handy. So this is what it's trying to say, which is over here when transfer between two devices on the same network. This is for uh, network layer. But if, for example, if we have two computers or two devices, they are connected with the, let's say, the switch, and by the way, switch is your intermediary device that is going to connect and make uh, these two computers communicate with each other with the help of switch. So this thing is called switch. So this is PC1, this is PC2, and PC1 wants to transfer some files to PC2. There is no network layer will come into play. There is no use of network layer. So network layer is always comes handy when these two systems are separated to each other, either physically or logically. Okay, and whatever the IP addresses are being used over here are different from PC2. If you're not familiar what IP address is, it's just like your ID card. If you are in the same city, you can communicate with each other. If you are in a different cities, of course, then you have to take a bus. You will go to that bus and then you will talk with that person. So this is just a layman example, just to make you understand uh, how physical layer or network layer works. I hope you get the idea. So let's talk about the data link layer takes packet from the network layer, and we know that network layer we deals with the packet and break into the smaller pieces called frames. So we came to know that at application layer, the term is called data. Then we have transport layer. The term is called segment. At network layer, the, it is called packets. But at data link layer, the data is called frames, as you can see over here. So like the network layer, the data link layer is also responsible for flow control and error control. So flow control and error control also happens in this intra-network communication. The transport layer only does flow control and error control for inter-network communication. And you might have a very clear understanding what is inter and what is intra. Intra is basically your local area network, LAN. You are physically or logically sitting there. But inter, you can take out from this word internet. And for the internet, you always have to leave your boundaries. So intercommunication is where geographically you are far away from each other. So this is where the transport layer only does flow control and error control when it is going to happen inter network communication. So LLC ensures the reliability of the physical connection. Okay, so when it comes to data link layer, we always deal with MAC addresses. MAC address, known with the many terms or names like NIC address, NIC address. It is also known as burn in address. It is also known as physical address. It is also known as hardware address. Then MAC address. MAC address basically is 48-bit address, and we will talk about a lot in detail. It is divided into 24-bit portions. The first 24-bit is used for uh, OUI, organization unique identifiers. Like Cisco has own identification for MAC address, HP has own identification, Juniper has own identification, Microsoft. Okay, so these all vendors used first 24-bit to uniquely identify this company or organization. The rest 24-bit is for the client. For example, if you are going to manufacture one NIC card comes with a MAC address, and for example, your company name or organization name is XYZ. So first 24-bit is denoted to your organization unique identifier, plus 24-bit you are going to randomly assign for your NIC card. Okay, this is not for the client, but basically when the client will install this NIC card, he will be having a very different or unique MAC address. So that is the whole idea of having MAC address. Then further MAC address is having two portions. One is LLC, and then another one is MAC. LLC is used for the upper layer to communicate with the upper layer like IP, IPX. And MAC is used for the lower layer like physical layer, which we are going to cover in the first OSI layer in the next slide. Okay, so it is going to be very complex, so I will just leave it as it is. So LLC is a protocol that provides reliable delivery of a packet over point-to-point links. The standard protocol IEEE 802.2 is the most commonly used standard. LLC is used in the Ethernet network and other technologies such as wireless LAN. It specifies how workstations cooperatively share the transmission medium. The IEEE 802.3 standards specify medium access method known as carriers and CSMA/CD. This is called carrier sense multiple access with collision detection. In old days, when we were using hub devices, these days we have switches, Cisco switches. They are intelligent devices as compared to hub. Hub is used to known as a dumb device. If two computers, let's say 1, 2, 3, 4, let's suppose we have a hub. I will denote it with the H. If this PC1 wants to communicate with PC2, and then we have 3 and 4. So let's suppose if PC1 wants to communicate with PC2, whenever this information will be sent to hub will just throw this packet everywhere. Okay, and meanwhile, if no one is talking, then only PC1 and PC2 can communicate. Other computers will wait for some time. Once this communication finishes, then they only be able to communicate with other device, just like a walkie talkie. Okay, if you're talking with a walkie talkie on a walkie talkie, you will say hello, how are you, over. Then the second person will say yes, I'm fine, over. So over is the term, you can take it in place of CSMA CD. So basically it tries to find the collision and tries to mitigate those issues. Okay, I hope you get the idea. A MAC address or physical address is a 48-bit number, as we have already talked about that. That identifies a specific network interface card. Every NIC has its own MAC address, which is usually printed on the back of the card. So as you can see over here, so LLC will speak with the network layer where we have routers, and the MAC at data link layer will talk with the physical layer, which we are going to cover in the next slide. So let's head over to the next slide, which is talking about the physical layer. And as the name suggests, physical, it means we are going to handle physically these cables. We have these RJ45 plugins, jacks. Then we have these hubs. We have these wireless devices, repeaters, then we have these wireless media antennas. So the physical layer, this layer includes the physical equipment involved in the data transfer, such as the cables and switches. This is also, uh, by the way, switches here, it is not talking about the Cisco, the manageable switches. Manageable switches work at data link layer. When we are saying switches, switches means these kind of hub, unintelligent devices. Okay, so they work at the physical layer. This is also the layer where the data gets converted into bit stream. And we know that bits are what? Bits and byte 1 0 1 0 1 0. So this is actually where these information will travel onto these physical cables, which is a string of ones and zeros. So the physical layer of the both devices must also agree on a signal convention so that the first ones can be distinguished from the zeros on both devices. So this is the whole agenda of discussing this OSI model. If this RJ45 cable, or sorry, CAT cable, let's suppose I have another CAT cable that I created, RJ45. So let's suppose whatever the data is transposed 1 0 1 0 1 0 1 0, whatever the data, for example, this is written A. So whatever the data that is converted into bits and binary will move over this physical cables, and when it will reach this my cat cable on other end, and if it does not know the convention, then I'm not going to receive the data, or even if I will receive the data, it will be a like gibberish. I cannot understand this language. So that is the whole idea of having ISO in place, international standard of organization, that will implement some rules that these bodies have to follow. So these rules will be implemented by this cable manufacturer, and the same rule is going to follow by this manufacturer. And then only the communication is going to happen. Otherwise, if they will not follow ISO standard, they are not going to communicate. Okay, so with that, our OSI topic comes to end here. And also, I'm going to stop this video over here because this is going to be another topic which is from the troubleshooting perspective. So I'm going to see you in. Okay, so OSI layer from the perspective of troubleshooting. So in the next slide, I have demonstrated one image that is basically representing all 7 layers of the OSI model. And let's start from where which I would like. Let's say from the application layer first of all. Okay, so as you can see, and we have already talked about what happens at the application layer. The user usually interact with the web browsers or email, something like that. Okay, we have so many other things as well, but most of the time we are having or dealing with uh, these web applications, okay, or the applications. So network process to application. So as you can see, we have DNS, we have www, we have point to point, we have email, pop, SMTP, telnet, or FTP. So if maybe these all layers are working pretty fine, then you have to check maybe application layer is not working because some firewall is there. Okay, so you have to go through many steps to double check why DNS is not working, why my web application is not working. Maybe the browser is outdated. The application you are trying to run on is not compatible with that browser. I have faced this thing so many times. Under the email, maybe you are not going to provide the mail exchange server properly. Okay, then maybe the FTP you are trying to access for the server, maybe the port 20 is closed. Okay, so many things you can think on application layer, and the application layer is going to be most hectic as compared to the other layer, because the application layer is where most of the protocols, as I have mentioned over here, are working. And maybe your firewall is in place that is uh, preventing accessing the applications under presentation layer. And we know that whatever, for example, if you are trying to search some website like google.com or jobskillshare.com, it is going to convert all those data into the presentation in some kind of encryption format. So as you can see, recognizing data like HTML, doc, JPEG, MP3, AVI, and sockets. So these all formatting is gonna happen at presentation layer. So if your application is working fine, means there is no any kind of firewall involved, everything is working fine, but you are going to get some kind of gibberish data. So it means this is a clear understanding you are having some presentation kind of issues, maybe the compatibility issue. One system can understand the format of JPEG, the other not. Then we have a session layer. It established the TCP, SIP, RTP, RPC name pipes. Okay, so as you can see, just you can imagine that this is one source and this is destination, and it between we have these routers, and then this computer wants to communicate with this system, but meanwhile some session or the bridge is created between these two devices. Then only the data can be sent or received. But if this bridge is broken, if the bridge or the session is broken, do you think your data will be transferred? No. If the establishment is not there, the session establishment is not there, there is no way you can communicate. So at the session layer, you have to worry about maybe session cookies. If you're not familiar with the cookies, kindly Google it and check what cookies are. And whenever, these days it is very common practice, whenever you are going to search any website, they always ask you to accept cookies. So this is the main idea. Cookies will not only having the session ID, but they will also keep the information of track if you are searching some contents from that cookies. So that is why sometime you also come across with this situation or the scenario that in a few days back you search about some, for example, flights, booking flights. Maybe you wanted to reserve some flights for some destination, and then after week you just close the session and then you just open the any website. You will see on the right or left bar, you will be seeing some advertisement related to your flights. This is why, because your computer saved that cookie with that information that you previously you were searching for those flights information. So that is why on the basis of that, so companies are very intelligent, they are using cookies for their advertisement purpose as well. That all happens at session layer. Then we have a transport layer. As you can see, these two persons are moving forward to send this information from here to here and then vice versa. It means we are going to transport end to end data from one source to another destination. And most common protocols that are being used are TCP and UDP along with ports. And by the way, we have 1 to 1024, and then from 1025 to 65535. These are well known ports. Well known ports. And these are not well known ports. Not well known ports or random ports. Why do we need these ports? We will talk about briefly in the next section. But just bear with me. In transport layer, we will be talking about TCP and UDP along with the ports. Okay, so we have to send information from source to destination in a correct format. Then this is again, maybe if you are not able to communicate with other device, maybe this could be using a firewall. And by the way, most of the organizations, most of the organization currently they block UDP, because most of your communication like Zoom, Teams meeting, YouTube. Okay, so such kind of these all they are using RTP, real time protocol, by using UDP, because this is unreliable, and we will talk about TCP and UDP in the next segment. But just keep it in mind. If you are having some transport kind of issue, just make sure that ports are open on receiver end, and the TCP and UDP are working fine. It is not blocked. And the network layer, as you can see, path determination and logical addressing. And most common things that happens network layer happens is routers. And I told you, when source want to read destination, for example, this is the server of job skill share server. Source want to reach to the destination, but uh, in between we have thousand and thousand of routers. It could be some ISPs routers. So your path is not going to follow the same pattern. It could have multiple paths. This is because of redundancy and plus optimal routing, because you want to reach to the destination from the best path. And in between, if routers have some kind of issues, for example, we have like IP related issue, maybe we are using some kind of BGP protocol, because BGP is the protocol that is being used for internet gateways. Let's suppose BGP is having some kind of flush issues. It has flushed all DNS, or maybe the router is damaged, or something happening. It is a clear indication that network layer is getting failed. So whatever, and the source, there is no problem. There is no problem with the firewall. There is no problem with the destination or transport layer. This is the problem in between, which is network layer. Then we have data link layer, and you can see at data link layer we are using switches, and these are manageable intelligent devices, by the way. So what could be the issues here? Could be the issues with the MAC addresses, and we could have many issues. So if there is any problem at the data link layer, you immediately need to go into the switches and take a look at that, what is going on. So as you can see here, this has to do with the physical addressing. It could have router MAC, or even the switch MAC, or even the router. Sorry, this is the router that is being used at a home. But if I'm talking about the ISP, these kind of routers are being used in ISP. And routers also have MAC address. In the future videos, I will be talking about why do we need logical addressing, why we are going to use logical address plus physical address together to make communication happen. Without physical address, logical address will not work, and for without logical address, the physical address will not work. And we know that logical address is IP and physical address is MAC. So they both will go hand in hand to communicate with any device on the network. And why? We will talk about later. In the end, we have physical, and as I said, I told you earlier with the scenario, the first thing you have to check is the physical cabling. This is fiber, by the way. You need to properly check whether this cable is working or not. And let me tell you another scenario or situation that I faced. I checked one of the employee whose internet was not working. RJ45 cable was working fine, and it was plugged into that console of RJ45, and there is a green LED was blinking, but internet still was not working. Then I went to troubleshoot these all other upper layers, but it didn't work for me. Why? Because this is why it is called first clearly check the physical cabling. When I clearly took a look of this RJ45 color coding, for example, we have these cables connected with plugged with this RJ45, and maybe two of the cables were loose. So just imagine how painful it was for network administrator. So these two cables, because all connectivity was there, so that is why LED was blinking fine. But two cables or two wires out of these 8 wires were loosed. So that is why it was not working. So the solution was I just ripped it off. I just ripped it off and then I spliced it again. Then it worked. Okay, so you can come across many situation scenarios once you will be working in a production environment. So let's do a Wireshark demo, and I'm going to see you in the. Okay, so I decided to divide these videos into maybe 3 or 4 because otherwise it will be very lengthy, like 2 to 3 hours, which I do not want. Um, Maybe if you are already familiar with the Wireshark, why you need to then watch the whole video and you can skip. Okay, that is why I've divided into small videos. So the Wireshark demo. If you are familiar with what Wireshark is, then it's good enough. Otherwise, Wireshark is a network protocol analyzer that captures packet from a network connection, such as from your computer to your home office or the internet. Packet is the name given to the discrete unit of data. A typical Ethernet network Wireshark is the most often used packet sniffer in the world. So as you can see on your uh, left side, so this is the snapshot of a Wireshark. It captured some packet. As you can see there we have a list of packets and is going to tell me from which source the packet came and which destination it is heading, what kind of protocol it is going to use, what is the size of that packet, and many more. And then if you will select this particular packet, it is going to give me the detail of that packet. And if you are a very good network administrator and you are clearly having good understanding about what protocols are, what ports are, what physical MAC addresses are, what the port numbers are. That is why I told you to remember port numbers not by name, but by having just by having the numbers. So just by remembering the numbers, troubleshooting will be very easy for you. And even if you are going to pursue network security career, network security plus cyber security career, then they are always talking about the protocols, number protocols, which protocols are allowed, which protocols you need to block, blah blah blah, and these kind of things. So you must have very clear understanding what ports and protocols are. So so let's head over to the Wireshark very quickly. So this is the main page of Wireshark. If you're already familiar, that's good. Otherwise, I'm going to give you a brief about how it look like and what happens. So basically, here we have these interface cards. Okay, local area connection. This is a NIC card, which I was talking about in my OSI layer. Network interface card has MAC address. And if I will pop up, as you can see, it is going to give me my logical address and IPv6 address and the physical address as well. So currently the scenario is I have my this PC which has NIC card, network interface card, okay, and Wireshark is running into it. Then this network interface card is connected with some cable to my home router. Home router. My home router has one logical address, let's say 192.168.100.1, and it might have some physical address. Then my PC is having IP 192.168.100.3, and it has its own MAC address. Okay, so this is the current scenario. So that is why when I will take you to the Wireshark, you can see this local area connection. And as you can see, this is heartbeat. You can see so many data is currently uh, uh, sending or being received. Similarly, we have this loop back adapter, and you don't need to get worried about this. And from here, you can see local area connection 9, 8. They have no address and it's not going to capture anything. So if you want to capture this network interface card, then you need to double click this one. So before this, I just want to give you overview about Wireshark. As you can see, this is the menu bar, just like other applications have. They have so many options. And then these are the shortcut toolbars. You can have the same thing, whatever you are going to do from the menu bars, they also having over here as well. Then we have this third bar, which is called the display filter. For example, we have multiple packets. Like we could have like TCP, we have UDP, we have FTP, we have Telnet, we have SSH, and so on and on and on. And you can see in one single communication, we can capture thousand and thousand of packets. So in order to single down those, for example, I just want to single down, let's say SSH. So what I will do, I will type SSH over in a display filter to filter out those SSH packets only. Got it? Okay. So from the point of perspective of OSL, by the way, when I will move along, you will have clear understanding about the Wireshark slowly and steadily. So it will start penetrating in your minds. So that is why I'm not going to waste my time explaining each and everything here. So very quickly, let's head over to local area connection, and I'm going to capture the packets. And as you can see, immediately it started to capture the packets like TCP, DNS, TCP, HTTP as well. And then if you want to stop, this is the stopping capture packets, this symbol, the red rectangle basically. So I am going to stop the capture. So currently from the perspective of OSI, I just want to ensure whatever the layers we were talking about. Let me clear this one. So whatever the layers we talked about, application layer, presentation plus session layer, I'm going to single down in the same layer. Then we have transport layer. Then we have network layer. Then we have data link layer. Then we have physical layer. So what I'm going to do, I'm just going to uh, correlate that with this. So as you can see, we have captured tons and tons of packets. Currently, I am on a frame 1. It means I am sitting over here. If you select TCP, you can see the things have changed, and now currently I am on frame 9. So correlate, I'm going to correlate. For that, what I'm going to do, I'm going to basically take a screenshot of this one. I'm going to take a screenshot, going to copy to clipboard, and I'm going to come over here and just a minute, I'm going to make a new and paste it over so I can write. So that is why, I have captured this one. So as you can see, we were talking about at the physical layer bits and bytes. So I was talking about bits and bytes. Let me select, yeah. So these, as you can see, bits and bytes. So it means on OSI layer in Wireshark, we are talking about physical layer over here. So this is representation of a physical layer. Then above physical layer, we have data link layer. And we know that at the data link layer, we are talking about the MAC addresses. So this is, you can see, Ethernet to this you can correlate with the data link layer. Data link layer. We have covered physical layer, we have covered data link layer. On top of data link layer, we have network layer, which is also called internet layer. So this layer representing network layer. Then we have transport layer, and as you can see, transport layer handles TCP and UDP. That is why we are going to correlate this section with the transport layer. So as you can see, the Wireshark clearly representing this as physical layer, data link layer, network layer, and transport layer. So it means whatever we have said or spoken in OSI layer session, Wireshark is saying, yes, you are right. So Wireshark is giving us a clear indication that whatever we have already spoken in OSI layer model, we are going to visualize in Wireshark. In the next lectures, we are going to go a lot in detail what these talking about what do we have inside this every segment or the capture. Uh, it's a story of next subsequent lectures. Okay, so don't worry about that. Okay, we have the frame as well. By the way, frame has nothing to do with OSI layer. It is just the indication that we are sitting on the capture packet number 9, and this is going to give us the complete scenario of all other OSI layers. So you can correlate this frame as the table of contents of single packet that we have captured. This is which is this one, this packet. So this is a table of content. The first thing is, by the way, the first this frame is the table of content. So you can remember it. Okay. So let's head over to our PowerPoint presentation. So I hope you get the idea about the correlating OSI layer with the Wireshark. So OSI layer from the perspective of cyber security. So OSI layer from the perspective of cybersecurity or network security. So let's head over to the next slide, which is talking about every layer and what kind of securities we can come across. Okay, so we already know. So I'm going to start from the layer one, which is physical layer. We already know the physical layer of the OSI model is responsible for converting data packets from the data link layer, layer 2, into electrical signals, and we have already talked about bits and bytes. Okay, so keeping data safe at the physical security layer allow unauthorized access and restricting access to critical servers. Security in the OSI physical layer comprises the enterprise's physical and site security concern, which includes all these aspects like access control, power management, environment management, smoke and fire suppression, backups, protections of the physical layer infrastructure. So when it comes to the physical layers security, the most important thing we need to keep it in mind is the access. And I'm going to give you my personal experience over here. I had one security IT room, not security, but IT room, which has many servers, and we call it data center, a mini data center. Okay. Then we have patch panels, we have some telephonic kind of uh, switches, okay, which has tons and tons of cables that go to other departments or the offices or the floors. Since I'm engaged with the hotel IT management or a hotel IT services, that's why we usually dealing with the floors, okay. So sometime what happens, and it has happened on so many occasions, that I have this IT room and I forgot to lock my IT room, and I went for the inspection, or maybe I went outside for a lunch. Then in my absence, what happened? Some housekeeping personals, they comes to my IT room. They usually knock the door. If I'm available, I will open the door. If I'm not, they try to open the door. Okay. So what happens? I have some CCTV cams installed in my IT rooms. Multiple CCTV LEDs that having the visuals of every floor, reception, and all these blah 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 things. Okay. So these sweepers, they come into my office, and by the way, every person has the habit to put their hands on top of some switch or something, like just to stabilize your leg, okay, something like that, to give a rest, something like that. So they are sitting and they want to rest their leg, and basically they are putting their legs on top of this switch, this telephone switch, which has very thin cables. So what they do, they end up maybe yanking out those cables. Okay, end up maybe this cable is going some floor's room where this phone is installed, and it is not working because this guy yanked out that cable, and he will leave. Once I will come back and I will sit on my chair, I will start receiving the calls from the reception. the room number 801 phone is not working. So I will go over there. I will check the phone and phone is totally dead. Then I will attach some device on that um, hotel room. On the other end, I will try to track down that cable first of all. And I will show you in one slide that what kind of devices you can use to troubleshoot what. I will come over here. I will check with that buzzer tool where this cable is heading to, and I will check that cable is unplugged. So that, the whole scenario or you know, uh, the scene, what I'm trying to um, make you realize over here that physical security is one of the very, very, very important aspect. So from that day, really, I always locked my door so nobody could enter in that room. So physical security is very important aspect. Similarly, you need to make sure your power management is working fine. You have smoking and fire suppression devices installed. You must have backups like we have UPS, universal power supplies. In case of power outage, you should have UPS in place. Then physical layer infrastructure, like on each floor we have these switches installed from where these cables go to every room. Okay, so if somebody come and unplug this device, I don't have any option, to figure out unless I will go reach and check that switch. So you have these cabins, you need to lock those cabins as well with a key. Okay, and similarly you have wireless access points over there as well. So you have to somehow protect those devices accordingly. Then we have data link layer, and we know that at data link layer we have switches. So as I said, first of all, we need physical security. We need to secure these switches wherever they are. Then, as from the paragraph, it is saying the data link layer is a primarily concerned with the physical addressing, line discipline, network topology, error notification, order delivery of frames, and flow control. So it means it could have these kind of issues. Error notifications, order delivery, flow control, frame issues. Okay. So devices such as switches and bridges work at this level. Understand the security threat that may occur at this level and how to mitigate. Some of these threats are like ARP spoofing. And by the way, when we will hit the network security program or the module, I will be talking about a lot in detail. But here I'm just going to scratch the surface. So we have some ARP spoofing, we have MAC flooding, we have spanning tree protocol. So if I will just take one example of MAC flooding. So basically the switch keeps the table of MAC address. So it will be having the table of MAC address, which basically is saying I have multiple ports on my switch like 1, 2, 3, 4, 5. 1, 2, 3, 4. On the first port, which MAC address or computer is connected? So this computer will be having some MAC address. This PC1 will having the MAC address of that computer in that switch. Similarly, on maybe second port, the router is connected and router has its own MAC address. So router MAC. Similarly on third and fourth. So this is how switches will keep the information uh, or correlate port with the MAC address. So what happens in a MAC flooding? This table has some capacity. This table has some capacity to keep information about MAC addresses. Let's suppose this switches can contain 1000 MAC address information stored inside the table. MAC flooding, what hackers do, they will flood ton and ton of MAC addresses, end up choking this table because it can only facilitate 1000 MAC address. But imagine if we have more than 1000 MAC addresses, what switch is going to do? It is going to bombard everything everywhere. Okay? So this switch will become a hub, a dumb device. So this is how hackers what will do. They will take a notice of every packet, because after that whoever is going to send the packet will be destined to everywhere. Everywhere means the hacker may be sitting on this device, and the hacker can get all the information about that PC. What is the MAC address, what is the IP address, what is means all details, nitty gritty details, and with the help of the detail he still can um, you know dig up whatever the information he or she want to. Okay, similarly we have span tree attack. So these kind of attacks happened at data link layer, so you have to look out on this. Let's head over to the next slide, which is talking about the network layer. At this layer there are many protocols, IP, responsible for routing, and we have already talked about routing of data and network information. It is important to understand how attackers could misuse of any of these protocols and gain access or spoof any network. Lots of security attacks that can happen here include denial of services act, packet sniffing, just like we are doing using Wireshark. All the Wireshark we are using for the positive purpose, but it can be used negatively as well. Okay, because it is giving me all information. So what hackers do, they can install some tapping device in between. Tapping device is just like a star kind of device. From here, this is going to destination. This is the source. And maybe the hacker is sitting in between with the Wireshark installed. So whatever the communication is going through this wire, this person or the this hacker is having a hands on to the those all information, and he can extract the information. Denial of services, basically, for example, we have job skill share website, and let's see, this website just can accommodate 1000 simultaneous access. So what attackers do, they can send so many TCP sync, and we are going to cover TCP a lot in detail next module. But they are going to send so many TCP sync attacks at once in a fraction of a millisecond that go beyond, maybe I don't know what this figure is, but something like that. End up choking this server. It cannot provide its services to the users, to the end users. Maybe you are studying some topics on that job skill share, but unfortunately, if somebody uh, launch DOS attacks on this website, you will not be able to access those services. So this is the main idea behind having DOS attacks. Similarly, we have ICMP and ping of deaths that works in the same DOS attack fashion. Then we have IP address spoofing, route index, backhole, and selective forwarding attack. That all comes under network layer attacks. Okay, so if you are interested, you can go one by one and you can take a look and read out what routing attacks are, what IP address spoofing is, what is ping of death. Under layer 4, which is talking about the transport layer, and transport layer, we know that transportation of a data using either TCP or UDP. So this is where the TCP protocol resides. To understand the security issues relating to the TCP or UDP protocol suite essential to cybersecurity. Some security threats that occur at these levels include the following: endpoint identification. By the way, this is not a uh, some attack, this is the mitigation. So endpoint identification, this is installed on your endpoint system to identify what kind of attacks are being happening. Okay, we have unauthorized internet access, sync flood, ping of death, smurf attack. So these are all related to kind of denial of service attacks that is going to happen at transport layer. Sync flood, as I told you, multiple syncs will be sent, okay, at transport layer. These like TCP syncs. TCP sync. Multiple TCP syncs are sent to that server, end up choking the bandwidth. Similarly, we can have access unauthorized internet access. We have Smurf attack, ping of death. You can read these all attacks. By the way, and these all happen at transport layer. Then we have a session layer. The session layer manages the establishment and tearing down of connection, and we already talked about it. These connections could require authentication, authorization, session restoration, tokens etc to set up. During this process, it is possible for the session to hijack through man in the middle attack. So scenario is very simple. Let's suppose we have this computer device, we have this server, and of course we have one session created on the basis of cookies. But if some man in the middle person is sitting over here and he captures this information about the session or the cookies, so he can malfunction this information and can hijack that session. Okay. So the fundamentals of using secure socket layer and transport layer. So the remedy is lies into SSL and TLS, transport socket layer, or also known as TLS as well, transport layer security. Similarly, the mitigation is SSH. If you remember, I talked about telnet. That is also one of the the victim uh, of the high session layer hijack attacks. Somebody can uh, extract this clear text password and then he or she can create its own session. But the overcome and the mitigation lies into SSH, secure shell, which is going to encrypt all data. So if the sender and receiver is over here, they are going to form one session, secure shell. This is encrypted session, encrypted. So no matter how many data this hacker is going to capture, these all will be gibberish, encrypted data. He or she cannot decrypt data unless until he is having or she is having some formula. And to break that formula, you require so much high processing power. Okay, so Kerberos is also, so these things are the mitigation, and this is also IPsec security protocols. So before sender sender device is going to communicate with the receiver device, they are going to create one secure IPsec tunnel. Then data will be transmitted across this pipe and will reach to the destination. And if the hacker is going to capture, he is going to capture nothing but some encrypted data which they cannot understand. In the last, we have presentation layer. Sorry, we have one layer after that. So sixth layer is presentation layer. The presentation layer ensures that the communication passing through are in the appropriate form for the recipient. Some of the services as this layer are data conversion, character code translation, compression, encryption, and decryption. For example, the malformed SSL request. So this happens as presentation layer. Attackers could use SSL tunnel HTTP attacks to target the server. Similarly, I have already talked about the SSL hijacking. So these all happens not only in the session layers as well, but at the presentation layer as well. So that is why application, presentation, and session layer are squeezed into one layer called application layer if we will talk about the TCP IP model. The OSI layer that we have talked about is the OSI layer, and opposed to OSI layer model we have TCP IP model, where these all layers have squeezed into one layer called application layer. Last but not least, the application layer. So this is the application layer where I would say 80% of the targets or attacks happens, because this is where the end user interacting. Maybe he is going to open an email received from a hacker, where it is most of the time it is written that you have won some prize. Okay, in order uh, to get that prize, kindly click on this link. So some URL kind of stuff is over here, and if you are not good uh, understanding the attacks, you will click that link. It will basically take you to the hacker malfunctioned website, which will be look like that this is real. Okay, basically hacker is going to fool you. So they will ask you, kindly provide your username, kindly provide your password. Maybe it will ask you to enter your this credit card information and something like blah blah blah, kind of thing. So these all things happens at the application layer. So let's read this paragraph. It's saying the application layer is the hardest to defend for several reasons. For a starter, the layer is the most accessible and the most exposed to the outside world through port 80, which is not clear. Sorry, which is not secure. Or the port HTTP3, which is HTTPS, which is secure, but still, there is a possibility hacker can hack this port as well. Secondly, it provides a service to application procedures that are located outside the OSI layer. According to the Gartner, and by the way, Gartner is a very good website that is going to give you, um, you know, uh, v- um, can say, going to give you a brief information about the attacks that is happening currently, maybe attacks happening in 2024, in 2023. Similarly, Gartner is going to give you information about um, one vendor versus another vendor. For example, if I will give you example of AWS versus Azure. Okay, so it is going to it is going to give you um, this versus kind of things. So Gartner is very good website if you want to go and just surf this website to take a look. So Gartner 70% of successful attacks occur at this layer. I said 80%, but maybe these days we are um maybe 90% are attacks are being happened on application. But as per the Gartner, 70% successful attacks are being occurred at this layer. So what kind of those attacks are? As I said earlier, denial of service attacks. We have HTTP flooding attacks. We have SQL injections, because in username we have text box, we have password, we have text box, and we have one button to submit. If you are very good programmer, what if you are very good programmer and you what SQL injections are, you are going to put one SQL in query. You are going to inject that SQL query inside that username box, because at the end of day this query is going to reach database server. and it will bring the uh, reply which hacker is interested in. So you can inject so many uh, SQL injections. Then we have cross-site encrypting, authentication, access control. The remedy lies into cryptographic algorithms. Crypto is encrypting a data. For example, if the data is A, I am going to encrypt into $1 2 X B J 3 into this format. Are you going to understand what it is? Okay, so this is called cryptography. Then we have session management. We have some kind of viruses happens at application layer. We have worms, trojans, and phishing attacks. These all happens at application layer. So I hope you got a very good understanding about network attacks. So OSI layer from the perspective of cloud computing, I'm going to stop this video over here and I will join you in. Hello and welcome. So from the perspective of cloud computing, how OSI layers looks like. Okay, so let's head over to the next slide. So as you can see, we have layer 1, layer 2, layer 3, layer 4, and layer 5. So we have total 5 layers in cloud computing from the perspective of OSI model. Okay, so first layer, we know that in the OSI layer, we have first layer is a physical layer, and this is also physical infrastructure. This is entirely in the hands of the cloud provider such as AWS. So whatever AWS basically is having the data center. So whatever the switches, routers, firewalls, cabling, whatever they are doing it, this is happening at the layer 1 of cloud OSA model. And this is 100% responsibility of AWS. So they are responsible for that, not the client. Then we have layer 2 is the hypervisor. If you are familiar with hypervisor, that is good enough. If you are not, by the way, JSS has extensive videos covering hypervisors in detail. So the software that allows the underlying hardware to be utilized. This is the abstraction between the true hardware and the virtualized hardware that we see. AWS uses Zen, Azure uses Hyper-V, and other uses KVM. Okay, so if you want to run, for example, we have one hardware. Just like if I will give you example of AWS, since we are talking about cloud, then hardware structures will have operating system, and top of it we have virtual hypervisors. Hypervisors. And what hypervisor will do? Hypervisor, I can just remember this with hypervisor supervisor. It will supervise whatever the applications or virtual machines VMs are running on top of it. So hypervisor is going to manage these virtual machines. By the way, we have a separate section for the virtualization. This is where I'm going to talk briefly about virtualization, but just keep it in mind that we have um, on layer 2 it is talking about the hypervisor. And by the way, these days we have a new concept called Docker or containerization. That is also a virtualization. Okay, so we have Docker engine, and on top of Docker engine we have containerization. So these are all called containerization. And in future, JS is planning to create a complete series about DevOps, where we briefly will talk about Docker engine and containerization in detail. The layer 3 is where we get our hands dirty. It means we are will do something. The software defined data center, SDDC, software defined data center, works at layer 3. From here we create our cloud accounts and start building stuffs. This is accessed via web GUI, command line tool, API, or other platforms in integration. And by the way, JSS has uh, extensive videos on AWS and Azure. For the AWS, we have created one basic series plus advanced series. And I recommend you, after you go for the CCNA, just beside CCNA, start to learn JSS, either AWS. From the JSS, either take AWS course or the Azure course. And if I'll show you a glimpse of layer 3 web GUI console, it looks like this. So as you can see, this is my web console, and it is going to give me the brief look about my AWS web GUI console. So you click services, you click all services, and this is alphabetically, it is going to give me all detail of service. So click on view all services. It will take me to the page where these all services are mentioned, like EC2 compute, S3, Amazon SageMaker, we have Code Guru, DevOps Guru, we have containerization here as well. We have storage, we have database, we have analytics. There are so ton and ton of things are available in the AWS management console. Okay, so that is the part of layer 3. So this console which I showed you comes at layer 3. Then we have layer 4, the native services. Then inside I show you S3 services, Lambda services, storage services, relational database services, such as for example EC2 services. These all comes at layer 4. This is where we create actual workload, store data, process information, and make things happen. So if I'll show you from AWS management console, so currently we are on the console. From here just type EC2, and if I'll take you to EC2, instance is running. From here you can create or launch instance of either Windows Server, Linux, Ubuntu, or whatever might be the case in your scenario. You can click launch instance, and then we will give the name of the server like Windows, for example, Active Directory server. Then I will come down, and then I'm going to choose Windows Server because I'm interested in Active Directory. If you have some another objectives, you can select accordingly. And then you need to go through these all options, and then from in the end you will launch instance, and you are going to create one Windows server uh, to get your hands dirty with. Okay, so these are all the things that happens at layer 4 of OSI model of the cloud. Then we have layer 5. So layer 5, as I said, I'm not convinced this is all the different to layer 4. So this is similar to the layer 4, but it is useful to distinguish it for the purpose of defining who has access. This layer is an analogous to layer 7 of the OSI. So that is the end user facing, such as the front end web applications in the interaction taking place on the mobile. So whatever the services you are going to access through mobile devices, IoT devices, or whatever might it be case, you are going to use layer 5. So from the picture, as you can see, physical infrastructure, building, power cables, hardware, and utilities. At second layer, we are talking about the hypervisor, which is could be Zen or Hyper-V. In the third layer, we are talking about software-defined data center, which is talking about basically the GUI or the CLI, which I showed you. Then on the fourth, native service or machine instance, we have EC2 virtual machine, RDS and S3, and application experience. Basically, we are going to access those applications at the layer 5. So I hope you get the idea. So let's head over to the next slide, which is going to describing basically OSI model with AWS, Azure, and GCP. So I'm just going to do a comparison between OSI model and AWS. So as you can see, the OSI model, application, presentation, and session, they have squeezed it into the AWS OSI model, and we are using application load balancer Amazon Route 53. So applications that are being used over here are comes under the layer 7. Then we have transport layer, and in a parallel we have AWS layer, which is talking about network load balancer, network access list, and security groups. If we are talking about network layer, in AWS, network layer representing VPC, VPC peering, transit gateway, site-to-site VPN, direct connect, and private link. If we are talking about the data link layer and physical, they have squeezed into one layer, basically the physical data centers, regions, availability zone, local zone, and edge locations. Similarly, you can compare this model with Azure and GCP as well, if you will.
In this bonus exercise, I'm going to show you a free tool where you can go through some of the different type of servers and protocols and things like that to whatever you have learned in this video. So let's go to a lab environment. So as a JSS member, you can go to your dashboard, click on practice labs, and here type 2019 sandbox, just like that, 2019 sandbox, and go ahead and click on your lab. Light and premium, both members should have access to this if you are an active member, and go ahead and launch this lab. Now, of course, this is something you can do on your home machine too, but I highly recommend you always use your lab machine. So if you have a virtual box or something like that, make sure to use that. Anything that you download, that is just a little warning. And whenever I'm doing something custom like this, it does not come with a support, so please do not reach out to the support. This is all custom, so try to follow everything step by step. So go ahead and turn on your PLAB DC01, PLAB DM01. We will use the DM01, but for that we do need to have the DC running. So let's do the PLAB DM01. Wait for it to fully come up. So once your machines are up, click on PLAB DM01. All right, once it's fully on, go ahead and click on Start, click on Server Manager, and then click on Local Server, and this option, i.e. enhancement security configuration, turn it off. So let's go ahead and turn it off, and let's close this again. Let's go back to our internet in the lab, and we're going to type google.com. Now this tool that I'm showing you is a free tool, and make sure to use your lab environment to download anything. Type MOBA Xterm, just like that, and then click on MOBA Xterm download, accept this agreement, and then let's go ahead and download this. So you see there's a home edition, so we're going to go ahead and download this. The portable edition, we need that one, and we're going to save that. So just give it some time, it's going to download, and open the folder. And here, let's go ahead and extract all of that. So we got this tool now. You can even take it in your USB if you want to use it. So I'm going to go ahead and right click on this, run it as administrator. So the purpose for me to show you this tool is to, now that you have learned about OSI layers, can you really find out which type of tools are used in different type of protocols? So if you go to the server, you can clearly see you got a lot of different type of servers going on, and each server will use this different type of protocols and ports. For example, if we turn on FTP, do you know FTP runs on which port? just a normal FTP. So it says the protocol is not secure. So if you just type yes, you see the port is 21. So going back to your OSI layers, you can then find out which protocol is being used and how it's being used when you use FTP. Now, the best thing you can do over here is to learn how to actually then use FTP. Like, why do we even use FTP? And that could be a good research for you. You don't need to really go too much deeper right now if you're new to IT and you're totally getting lost. That's fine. But what you should do, at least start to find out what is FTP used for. Another one is the HTTP server, which is basically your web servers. And when we enable that, you see the port changed into 80 now. So right now our computer is listening on port 80. So if we open or we type something on our web browser like localhost, it should open something. So let's go ahead and actually try that. If you go to uh, internet and type localhost, you see it's listening. I mean, it's open. Port 80 is open right now. That's amazing because now from this one tool, if you were using Wireshark from the lab, you can now actually run this tool and find out what's on port 80. Is it open? And Wireshark will also give you some information. Another cool thing about this tool is that you can actually come and open other telnet servers and things like that. I already mentioned the FTP. You can check the FTP through FTP clients or CMD, telnet, VNC. There are many other ones too. So the other thing that you can do in this tool is to actually do the sessions here to learn something more. Like for example, sessions here. So you could connect through SSH and then find that out. Like why do we use SSH? And in most cases, you're going to need to do routing and switching and other Linux type of stuff, and that's where it's really going to be used. And then you will have telnet here, RDP, FTP again. So if I wanted to connect to even my own FTP right now, I could do that by clicking here and just typing the IP of the current machine and the user, and it will probably open that FTP that I just enabled. So you see, at one point I did something on the server. So I made the server, I made the connection, and I'm listening and I'm accepting other people. And on the other end, when you have the connection tool right here and you do the FTP from here and connect to that server, that's the client side. So you could see everything even in this one computer. Of course, in reality, you would be doing FTP on another computer and connecting to the server. So maybe later on, when you get better, you should open up a new lab and then run this tool and connect back to this server and use Wireshark and other tools to find more about how layers are working, how you can break down things. But again, I'm going to remind you, if things are getting too much at this point and you're too new, you shouldn't be taking too much stress at this point because you got to learn a lot of things later on. So there are other things you can do if you have, let's say, FTP, HTTP, and other things running like this, and let's say you have sessions and you want to do some sort of Wireshark style type of learning. You can go to tools, go to network packet capture. It's going to give you an adapter here, and don't display the raw packets and click enter. So right now, whatever is happening in your computer, it is going to give you that packets. So we know that TCP is basically the one that you're connected to. Right now, this is the lab that you're on. Basically, that's what's going on in this. Then there's some DNS stuff going on. There's some acknowledgement going on right here, and there's a lot going on in this computer. Now, you have used Wireshark, or you have at least seen Wireshark, and you also looked into another tool, MobiXterm. Now, these are just small tools. Wireshark is pretty big, but we have many other tools like that. Now, as a new professional in IT, you're not supposed to just go and start learning this at master level or at a very experienced level. Just know that there are tools like this available, and that's how you get to learn things. So open it and try to understand when you go to the web browser, www, and see which protocol that you use. Then run some FTP and see if you can find which protocol is being used, SSH, and try to just figure things out first. Because that's exactly how you're going to learn things. Later on, you're going to learn more and more core skills like DHCP, DNS, IPv4, V6 in a very deeper way, just like what you have seen for OSI. That way, you're gonna learn everything and break it down, and the rest is gonna be just. It doesn't matter where you go in your life in IT, cybersecurity, cloud, more infrastructure engineers. It doesn't matter. You will use all of this information later on. Now, next, you should focus on some of the interview questions. Try to find good answers. Use ChatGPT. It's a new tool in our era now, ChatGPT. Yes, AI is not going to take over our jobs at any point at this stage right now, because it's not something that we're seeing, but AI can certainly help you. You can say that these are the interview questions that Kamran will discuss next, and then find some good answers and create some Q&As for yourself as well, because all of this information that you have learned, you can probably create like almost 100 questions just by going through this video. So that way it's going to really help you retain some of the information, and also it will help you on the job.
So I hope you get the ideas. Let's start over to the next slide, which is common interview question and assignment. So I'm going to show you the possible interview questions. What does the acronym OSI stand for? What are the layers of the OSI model? At which of the OSI model path decisions are made? How can data be transported in different layers? What is the function of a network layer? What is the importance of the physical layer or the OSI model? Which layer performs error detection and flow control? So look out on it. How does network administrator detect the problem? What is the data encapsulation? Explain role of the transport layer. So these, encapsulation we are going to discuss in the next section. But just for the sake of knowledge, you can search the Google from the Google and you can answer the query. But in the next segment, we are going to explain about the encapsulation. Okay, so with that, our long session comes to end. I hope you enjoyed this session as much as I did. And thank you for your time. And I will see you in the